So hello everyone, I am Arkadeep D and today we will be discussing about maximum subarray sum question. So the question states that given an integer array nums, find the subarray with the largest sum and return its sum. So before proceeding forward, let us first understand what is a subarray. So a subarray basically means a contiguous segment of an array from a given starting point to a particular ending point. So if we only take -2, it is a subarray because the starting and ending point are same in this case. Similarly, -2, 1 is also another subarray. Similarly, -2 to -3 is also a subarray. Similarly, 4 -1 to 1 is also a subarray. So it is a contiguous segment of that array from a particular starting point to a particular ending point. So now the concept of subarray is clear. We can proceed to find the maximum subarray with the largest sum. So if we consider this subarray -2 and 1, we can see that the sum of this subarray is -1. Okay. If we consider this subarray, we can see that the sum of this subarray is -4. So obviously -1 is a better sum as compared to -4. So obviously this subarray has a larger sum as compared to this one. So in this way, if we check out for all possible subarrays, we will find that this subarray 4 -1 to 1 has the largest sum, which is 6. Similarly, in this case, there is only one element in this array, that is 1. So the largest subarray sum will be 1. In this case, we can see that there is only one negative element and all the remaining are positive element. So what we can do is we can just take all the positive element and sum all the elements in this array and sum them. So answer is 23. So there are three approaches of solving this question. One will be an ONQ approach. One will be a ON square approach. And another one will be an ON approach. So let's first discuss the ONQ approach. So as I had mentioned earlier, that a subarray is basically a contiguous segment of an array from a particular starting point to a particular ending point. So what we can do is we can fix a particular starting point and we can fix another ending point, and then we can find the sum of that subarray and return the maximum sum from all such subarrays. So that's what I have done here. That I have fixed a particular starting point. So I represents the starting point and j represents the ending point. Then I have defined a variable named sum initialized to 0, and I have also initialized another variable answer. So it is basically initialized to int min, which is basically -2 to the power of 31. Now I have defined another loop from I to j. So the purpose of this loop is to find the sum of all the elements in this array from the ith index to the jth index. Once all the sum is taken, I am comparing that sum with answer. So this line basically means if the value of sum is greater than answer will be equal to sum. Otherwise, answer's value will be same as its previous value. Let me make it clear. If sum is greater than answer, then answer equal to sum, else nothing. So this basically means that if the sum of this subarray is greater than answer will be initially equal to sum. So obviously this will work for the default test cases. So it's accepted for the default test cases. But if I click on submit, then you will find that the time limit exceeded error is coming. So it basically tells us that we have to optimize our solution further. So since ON cube is done, let's try to figure out if we can make it ON square. Okay. So Since the purpose of this loop is to set a particular starting point and the purpose of this loop is to set a particular ending point, what we can do is we can find the sum from this particular starting point to this particular ending point. So in this way, what I'm doing is, as I'm going from this starting point, suppose in this case, suppose this is my array 1, 2, minus 1, 3, 4, 5, 6, 10, and suppose I am fixed this starting point, this is my I, and suppose I have to traverse till 5, this is my j. So what I can do is I can traverse from I to j, and while I am traversing I can find the sum of all the subarrays. So initially the sum will be 0, but when I am in the 0th index the sum will be 1, then I can add 2, then I can add minus 1, then I can add 3, then I can add 4, and then 5. So in this way I can find the subarray from I to all such j's, all such k's basically, such that k is less than or equal to j. So the sum will be equal to 1, then it will be equal to 3, then 2, 5, and 9, and then 14. So this way I am creating a running sum, and this running sum is basically equal to the subarrays starting from 0 to 5. There's some issue. So the error is rectified. I have to just make it j instead of I. So this is an O(n) square approach, and you can see that it is getting accepted for the default cases as well. But if I click on submit, I will get the same time limited exceeded error. So it basically tells us that we have to optimize it further. So the only remaining approach is O(n). So let's see how we can make it O(n). Now we can use a greedy approach. Since this array can consist of both positive and negative numbers, so suppose this array consists of only positive numbers 1, 2, 3, 4, 5, and 6. So what will be the maximum subarray sum in this case? It will be equal to the sum of all these elements, right? Sum of nums. So we can generalize the fact that if the array consists of only positive elements, then we can find the sum of all the elements in the array and return that answer. But suppose if the array consists of only negative numbers, minus 1, minus 2, minus 3, minus 4, then what will be the maximum subarray sum in this case? It will be equal to the highest number of that subarray, that is minus 1, because since it is consisting of only negative numbers, there is no point in taking two negative numbers, because it will decrease the sum further. So if we use greedy approach, logically we should take the maximum number in this case. So we have to take only minus 1. Suppose it consists of both positive and negative numbers, then we have to select a particular subarray for which the sum is maximum. So what we can do is we can define our sum variable outside, because we are only creating one particular loop, and we can add this value of nums I to sum. So if I'm getting 1 will be added to sum, it will be equal to 1 then. If I'm getting 2, it will be added to sum, so sum will be equal to 3. And then if I'm getting 3, it will be added to sum, so sum will be equal to 6. But when I'm getting minus 4, if I add it to sum, the sum will be equal to 2. So since the sum is positive, we can continue further, and then we can, if we add minus 5, 2 plus minus 5 is minus 3, so sum is getting negative. So what we have to do is we have to select the maximum subarray sum in this case. So if we use our logic, if sum is less than 0, we can set sum to 0, and we can also select a maximum sum in this case. So it basically tells us to add all the nums element one by one and to compare it with answer. If sum is greater than answer, answer will be equal to sum. Then if the sum is less than 0, so in this case, if the sum is already negative, there is no point in continuing with this negative value, because it will decrease it further. So we are setting sum to 0 before adding the remaining elements. So if you see, in this way we are getting accepted for the default test cases, and if I click on submit, so it's working. It's an ON approach. We should not use this runtime number. Like, we should not give a lot of focus on this runtime number. It varies as we click on submit. So if I click on submit another time, I will get a better runtime value. So it's okay. It's an ON approach. So let's visualize this approach once again. So suppose if I have values 4, minus 1, 3, 2 and minus 5. Cardian approach tells us to add elements one by one. So if I have sum which is equal to 0, first we will add 4 to it, so the value of sum becomes 4. Then we will compare it with answer. So answer is equal to int min initially. So after getting the sum value 4, the answer will be equal to 4. Then minus 1 will be added to sum, so it will become 3. But the answer is 4, so answer value will remain 4. Then we will add 3 to the sum, so the sum will become 6. 6 is greater than 4, so answer will become 6. Then we will add 2, so sum value will become 8. 8 is greater than 6, so answer will become 6. Then if we add minus 5, sum value will become 3. 3 is less than 8, so answer value will remain 8 as is. So we can see that the maximum subarray sum in this case is 8. It is the subarray 4 minus 1 3 2 for which the maximum subarray sum is 8. Let's take another example which is consisting of negative values at the start, minus 2, minus 3, minus 4, 5 and 6. Initially the sum is 0 and the answer is equal to the minimum value. So if we add minus 2 to sum value will become minus 2, and answer will also will be equal to minus 2, because answer is equal to int min. Int min is obviously lesser than minus 2, so answer value will be equal to minus 2 as well. But before proceeding further, we will set sum equal to 0, because we do not want, because since the value of sum is already negative, we do not want to stretch it further. So sum is 0. Then we will add minus 3 to sum, so it will become minus 3. But since minus 2 is already greater than minus 3, so answer value will remain minus 2 only. Since once again the sum value is less than 0, we will set it to 0 before proceeding further. So then we will add minus 4 to it. So the sum will be equal to minus 4. But minus 2 is already greater than minus 4. So answer will remain minus 2 only. Okay. Then we will add 5 to sum. So the sum value will increase to 5. 5 is greater than minus 2. So the answer value becomes 5. Then we will add 6 to the sum. So sum will be equal to 11. 11 is greater than 5. So answer value will become equal to 11. So this states that the maximum value of the largest subarray sum is 11 for the subarray 5 and 6. So I hope this approach is clear. Thank you.